Today we will be discussing electron configuration, but before we begin, we need to go through some vocabulary. Electron configuration is the distribution of electrons of an atom in atomic or molecular orbitals. An orbital is the region in an atom where there is a high probability of finding electrons. A period is the horizontal row of elements in the periodic table. A group is the vertical column of elements in the periodic table. Elements in a group share chemical properties. In order to understand electron configuration, it is important to first understand the periodic table. The S block is represented by the green region, the D block is represented by the red, the F block is shown in blue, and the P block is the black area.
The S block, also described as sharp or spherical, is composed of the first two groups of the periodic table, or the alkali and alkaline earth metals. The D block, also known as diffuse, is made up of the transition metals group 3 to 12. The F block, also recognized as fundamental, is the group of inner transition metals. The P block, also described as principal, is composed of the last 6 element groups of the periodic table, excluding helium. Regarding atomic structure, the S, P, D, and F blocks are known as subshells or sublevels. Bohr's model, proposed by Niels Bohr, shows the distribution of electrons within an atom. There are various energy levels where electrons could potentially be found. The variable n represents the shell number. To find the number of electrons that could fit on each energy level, we must use the equation 2n squared. When we plug in the shell number into the equation 2n squared, we find out that the n equals 1 shell can only have 2 electrons, and the n equals 2 shell can only have 8 electrons. N equals 3 could only have 18 electrons. N equals 4 can have a maximum of 32 electrons, and so on.
If we take a look at each block again, for example, the S block, we see that there are 2 groups. We divide this by 2 and we get 1. That means that there is 1 subshell. When we divide the number of groups in the D block by 2, we get 5, so there are 5 subshells in the D block. When we divide the F block by 2, we find out that there are 7 subshells here. Lastly, there are 3 subshells in the P block. For example, each one has 2 electrons inside because they completed the suborbital. However, 3p5 only has 1 electron in one of its subshells because it did not reach the number 6, which would have given it its full 2 electrons. We see that those that have the letter S only have 1 subshell, and those that have the letter P have 3 subshells. If there had been ones with the letter D, they would have 5, and those with the letter F would have 7. The number in front of each represents the energy level that the sublevels and the electrons reside in. 1s2 will go in the first energy level, 2s2 will go in the second energy level, 2p6 will also go in the second energy level but will add 3 subshells. 3s2 will go in the third energy level, and 3p5 will also be added to the third energy level, but one of its subshells will only have 1 electron.
First, we will show you the long way on how to write the electron configuration of an element. For the example, we will use the element zirconium. First, you start off in the top left-hand corner of the periodic table and list the energy level, the block, and the number of elements that you pass in the block as you move across the periodic table. First, we pass 2 elements in the first energy level in the S block. That would be 1s2. As we go on, we pass 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and 5s2, until we reach zirconium. We stop at 42 because that is where zirconium is located. Though it is useful to know how to write the electron configuration of an element using the long way, there is a much faster and easier way to do it. First, you locate the first closest noble gas before the element you are trying to write the configuration for. Using zirconium again, krypton is the first closest noble gas located before zirconium on the periodic table. First, we write the symbol of the noble gas in brackets, and then continue writing the electron configuration like normal, starting from the noble gas you decided to use. And that concludes our presentation on electron configuration.